And recording has begun.
Great. Thanks, Brett. Alrighty, everybody. Again, a good day to you wherever you are, whatever time zone you're in, either morning, good evening, or good night. I'm going to talk here in this session, our fourth session here. We're going to talk today about metadata. Going to take a deep dive on that. Again, for those who are not familiar with me, my name again is Jim White. I am with Dell. The person who is behind the original Fuse product, which became EdgeX Foundry. My email address is here on the board. Welcome comments, questions, concerns at that email address. But at the end of the day here, at the end of the hour, I'll also present you with some other areas where you can post questions or additional comments through things like our Rocket Chat or email lists for our EdgeX Foundry project. A little quick side note here before we get started in our technical talk today. I want to give a shout out. Had a lot of great help from the community last week. In London, we met for the first time in a face-to-face meeting, just the tech folks, no marketing people or managers allowed. It was just technical folks, and we talked about what is going to be in what we call the Barcelona release. The Barcelona release is going to be our first community release of EdgeX, and it's going to coincide with the IoT Solutions World Congress to be held in Barcelona during October 3rd and 5th. I'd ask you, please, if you have a chance today or in the next couple of days, go out and visit our wiki site. And on our wiki site, you'll find a roadmap section of the wiki. In that wiki, we've listed out our MVP. We've tried to provide some guidance about what it is we think we want to produce by that first release. We've also laid out some additional elements that go to other releases. We have a second release coming out in the spring, we think, which we have codenamed California. And we're starting to kind of lay down some tracks in terms of what we think will be in the future EdgeX releases. So I'd really welcome your input. Let us know where you think we need to vary that. Let us know what you think needs to be added. And of course, absolutely, if you have other ideas and can contribute, we would absolutely welcome those. And now that we're starting to get our arms around what is going to be produced for these releases, if you have an idea about how you might be able to contribute or want some ideas about how to contribute, get in touch with me. Be happy to provide you with a list of what I think are some great project ideas where we need some assistance, and even maybe some of those side projects that wouldn't necessarily fall under what we call minimum viable product, but are great ways to get introduced to the EdgeX community and start working on the code. Okay, so enough early entry there to MVP, but please, if you will, take a look. We'd greatly appreciate your help and assistance in letting us know if you think we're on track there. So what are we going to be talking about here today in the EdgeX Foundry Tech Talk? Well, today's topic, as I mentioned, is about metadata. For those who were on the call last week, actually 2 weeks ago, because last week we were in London, but 2 weeks ago we talked about core data. Metadata is a pretty chewy, maybe one of the chewiest, and chewy is a word I use to maybe make complex sound a little bit easier, but it's one of our thickest microservices in EdgeX. It is really at the heart of understanding how EdgeX operates. So we're going to take a look, first dive into metadata today. We're going to look at its makeup, including what are the technologies and libraries that make metadata work. We're going to look at its object model. And as you'll see, the object model for metadata is much more complex than the metadata than the object model for core data, for those of you who may have participated last week. So we'll get into things like device services, device profiles, addressables, all sorts of elements that we'll be discussing here over the course of the next 30 minutes. Going to provide you an outline of what the REST APIs are into metadata. How can you interact with it? How do your applications interact with it? I won't get into every single API. In fact, the API around metadata is huge, but I'll at least kind of categorize things and walk you through what's out there so you get a general sense of what you can do with metadata and or how you can start to look at metadata from your application's perspective. We'll also look at some important configuration settings, maybe not as many configuration settings as you would see in core data, but there are some things you can adjust. In particular, we'll talk about how you can set up for notifications, and we'll look at how persistence in MongoDB is handled. And as always, we'll try and leave at least the last 30 minutes or so for questions and answers. And these are questions that you might have about metadata or anything at large with regard to EdgeX Foundry. The sky's the limit there. Let me know whatever your questions are. What questions we don't address today, please, again, feel free to post your question on EdgeX Rocket Chat. And if you can't find that, if you go to the EdgeX website, you'll find a link through the developer section of that website that takes you right to our Rocket Chat area. One note, we're going to look at what's called metadata part 1 today. Metadata is big, it is complex, and there are lots of parts of it. So my super genius in residence at Dell, Tyler Cox, is going to be covering next week's session. He is the father, maybe the genius behind what is the device service SDK and device services, and in particular, he knows lots about metadatas and metadata profiles. So I've asked him to come in next Thursday. It'll be next Thursday morning at 9 a.m. Eastern Standard Time, or sorry, Eastern Daylight Time. And he's going to cover more of this metadata topic. In particular, going to talk about profiles, going to talk about how provisioning happens with metadata, and particularly provisioning involves also working with device services. So that next level down, what we call the south layer inside of EdgeX. So stay tuned next week for Tyler Cox. What a great asset we have to the project in Tyler. He is a phenomenal resource. And if you haven't had a chance or a pleasure yet to speak with him, join the call next week. He'll really set up the discussion around this topic, but also answer lots of other questions you might have about things like the SDK, which will certainly be a topic we've got coming up in a future EdgeX talk. And Tyler there is a man who has a face that could be available for TV, unlike me, who has a face for radio. So I think you'll find that discussion pleasant. And if nothing else, you'll enjoy the soothing tones of a young man who's got a lot to offer. Okay, so again, the focus of today's topic is on metadata. To kind of pull you back out to the 100,000 foot level in EdgeX, what does that mean? We're going to be focusing in on this block right here, the metadata block. You will notice that it does have a database associated with it. Again, we're going to use MongoDB as our reference implementation for the database underneath metadata. More on that coming up again just in a second. For those who were not on the call last week, the call a couple weeks ago, I should say, was on core data. So with our discussion here today and with Tyler's talk next week, that will have covered a big chunk of what really are those core services at the center of EdgeX. So what is metadata's role? What is its purpose inside of EdgeX? This is really the repository of knowledge about what devices and sensors are connected and communicating with EdgeX. It is what we use to provide background information to lots of other services about what is connected, what they're relaying in terms of their sensor readings, how to communicate with them. So other services like core data and command and any kind of analytics package you have would certainly be dependent on metadata to understand and get an appreciation of what is actually coming up through this EdgeX system. So specifically, metadata has some jobs. It manages information about the devices and sensors that are connected and operated by EdgeX. If you will, it's the repository of what is actually physically connected and how do I communicate with that particular sensor. It knows about the type and the organization of the data that's going to be reported by those devices and sensors. If you're a thermostat, metadata would be where you would go to understand what types of information, for example, temperatures, that thermostat are going to report. What formats are that temperature data going to be in, things of that nature. It also knows how to send commands to the devices and sensors. It knows what it is that those devices and sensors use to serve as, if you will, the API to how to set the particular variables or set the information inside those devices and sensors. How do you actuate those devices and sensors? So it has, or it is the source of information about how to get information out of devices and sensors and how to actuate back down to devices and sensors. Now, importantly, metadata is that repository of knowledge, but oftentimes people also expect that metadata actually does the work, meaning they expect maybe metadata to actually know and do the data collection. That's not true. Metadata doesn't do the data collection. It knows what should be collected, but it lets core data manage the collection of data along with device services. People expect metadata to be able to issue commands since it knows about commands. Again, not true. Metadata has the information about what commands are available, but it leaves the command actuation to another one of our core services that we'll talk about in an upcoming talk called the command service. So metadata is nothing more than a repository of knowledge about what's connected, how it's connected, and how to communicate with it. When metadata first comes up, it knows nothing about and does nothing about what is out there in the EdgeX system. In other words, it comes up as a novice and ignorant database, or if you will, ignorant knowledge system. It depends on things like device services to then come up to start reporting in and feeding in information about what devices and services are out there. It may also depend on things like humans or other systems to make API calls into metadata to define what new device services, devices, and such are part of the EdgeX system. So metadata, as you may be or hopefully starting to get an appreciation of here, comes up really without knowledge, and it's only through the device services at the south end or other systems, other applications that nice little Windows message there. Hang on there, folks. That it depends on those other services to provide that information, which it then shares with the rest of the EdgeX community, with the rest of the EdgeX microservices. Now, we built metadata so that it is a wholesale warehouse of knowledge, but it also offers us some ability going forward to do things like provide security and protection around that data. We don't want nefarious activities going on about learning what devices may be connected to EdgeX and or trying to execute commands through them. So this facility, while it is a warehouse of knowledge, also provides us a level where we can start to attach things like some security around it. Not there yet today in EdgeX, but certainly something we'll be looking at going forward. So it provides a warehouse of information, giving us an indication of what's coming through EdgeX, what is going to be used to command those devices and sensors. Oh, by the way, it also helps us to ensure that that data we're getting does conform to our expectations. If a thermostat says it's reporting something in a numeric form that is going to be, say, degrees Fahrenheit, we might have certain expectations around that. We don't want to start to get strings that don't look like numbers coming up as part of that sensor data. So it also offers, if you will, a way to help kind of comb through the data and filter that data and make sure we're getting what we expect from things like devices and sensors. So that's metadata's role. Now, what makes up metadata? What is the technology behind the scenes in this microservice? Well, it is today written in Java, largely written with the Spring framework on top of Java, using Spring Boot and things like Spring MongoDB at its core. These are all technologies used, Java libraries, if you will. They're used underneath the covers. It follows a Spring MVC pattern and uses REST communications as a means to communicate with it today. Again, if you followed the discussion from a couple weeks ago on core data, these are all absolutely the same as what you would have heard from core data discussion. We use Mongo database underneath the covers, just as we use with core data. Now, one thing to note here is that if you are somebody who's familiar with Mongo, in EdgeX, what used to be Fuse, we have a single instance of Mongo running. But inside of Mongo, we've separated the core data collections from the metadata collections, meaning that essentially these are treated as two different databases. Now, while we have them running in a single Mongo database instance, that's for convenience and resource constraints, it allows us in the future to think about separating these two if we need to. And in fact, we've actually done that inside of Dell. We've had core data running in something like SQLite and had metadata running in Mongo, or vice versa. It allows for us to choose independently which database mechanism is used underneath the covers to persist the data in each of these types of microservices. Today, they're both housed in a Mongo database, but they're separate collections. Dell's created also partial Golang replacements. Sorry, gang, there should be a typo there. That should be metadata there. We've actually implemented both core and metadata replacements. In fact, one of my colleagues, Ryan Comer, is actually furiously working on trying to get out a metadata replacement service in Go to help reduce the footprint, help to improve the performance. We're hoping that maybe these services are going to be available towards the end of the year. This is going to have no effect on the APIs you see today, no effect on the functionality that is provided today. That's the beauty of a microservice architecture. You can replace the underlying implementation, but everything else about the system remains the same. Okay, let's get into some of the heart of what makes up metadata. We talk about inside of Dell, we talk about the metadata triumvirate, which means that there are essentially three different types of objects, three model objects that are core to how metadata operates. These are what are actually persisted. These things are actually persisted inside of the metadata repository, inside of the Mongo database for metadata. The first one you need to understand is a device. As its name implies, this represents a physical device or sensor that EdgeX is connected to. It might also be, however, something like another gateway. It could be another EdgeX instance. It could be some other system. For example, we all know that there are products out there that we're talking about integrating with regard to EdgeX, things like IoTivity or Cura, or fill in your favorite system of choice. Those could be represented as a quote-unquote device as far as metadata is concerned. It is the thing, but that thing is a little bit of a loose representation. Anything that is representing or sending up data into EdgeX and may need commands sent back down to it is represented as a device inside of metadata. Each device is going to be managed, as we say, by EdgeX, meaning that we'll know when it's connected, we'll know when it leaves, we'll also keep track of where it's located and how to communicate with it. Each device must have a unique ID and a unique name associated with it. We chose to have both of these because an ID usually is some sort of database generated identifier, something that maybe Mongo, for example, would generate. We also wanted to have a name, something that you or I as humans can easily associate with a device, gives us a better handle on that device. And we do require that each of these be unique, meaning that even a name that you may associate with your device has to be something you choose that makes it differentiating from any other device connected to EdgeX through metadata. So that's what a device service represents. It represents a physical device or sensor, or again, something that looks like a device or sensor as far as EdgeX is concerned. Device service is the next thing we want to talk about. Device services and metadata represent an actual microservice out there, a device service microservice that manages one or more devices. So when we have some sort of device or sensor out there in EdgeX, we actually have a device service microservice that manages those devices or sensors. Inside of metadata, a device service physical microservice is represented by a device service object. So this is how metadata kind of keeps track of which devices are out there, which device services are associated to. And lastly, we have what's called a device profile. What is a device profile? For those who come from, say, an object programming language environment, think of a device profile as being a class where a device is the object instance that's made from the class. In other words, it serves as a template, if you will, a classification of device. You and I might both have thermostats in our house, and they pretty much operate in the same way. That would be a profile, a thermostat profile. But your thermostat, the actual instance, the actual physical device or sensor, is probably quite different than maybe my thermostat. So the actual device may be a little bit different, but it serves with the profile to have a template to be able to talk about them generically and know generically how we can speak to them and how we can get data from them. So a device profile provides essentially the generic characteristics of types of devices, what they can send, how they get their actions taken care of. Each device must be associated to a single device profile. And that device profile and the device services, as we'll talk about more next week, will come a little bit more clear about how those profiles are used by things like device services, or how they're used by the commands in our command microservice to understand and know how to communicate with a specific device. Device profiles also have a unique ID and a unique name. Just like our device services and our devices, everything is uniquely identified by this database generated ID, as well as a human provided, or if you will, at least some sort of more human understandable name that we can identify everything by. So this diagram helps to provide you a little bit of a pictorial on how these things are associated to one another. The device must have a device profile, and that serves as a template for devices. And again, device service helps to manage one or more devices, and it's actually represented by a physical device service that's out there. Now, to give you a little bit of a picture into the device profile idea, again, this is going to be the purview of Tyler Cox's talk next week, get you into a lot more details, see how EdgeX actually provisions devices and works with device profiles to make device services and the whole metadata and core data systems understand them. But this gives you a little bit of a high-level example of what we mean by a device profile. Again, let's talk about something like a thermostat. Let's even maybe be a little bit more specific. Let's say that we have a device thermostat device profile. So we've got a lot of thermostats out there that speak BACnet. We would develop a profile that would provide the general characteristics of those types of thermostats. How do you communicate with a BACnet system through the BACnet protocol? What types of data would a BACnet thermostat provide? So this profile described in a YAML language, as Tyler will walk you through, describes the type of data that a BACnet thermostat would send, and it also provides a description of what types of commands you can send down to that BACnet thermostat and what parameters and things you would actually send to it to actuate that BACnet thermostat. In other words, maybe setting and getting the cooling set points. Now, this is a generic mechanism. It's describing all BACnet thermostats. Inside of metadata, the profile is a generic template. Instances of our device that are associated to this profile would be specific thermostats. Maybe it would be Jim's living room BACnet thermostat would be an instance of this profile. Maybe it would be Jim's kitchen BACnet thermostat would be another instance. They all abide by the same general characteristics, but each instance obviously would be then able to send different data and be able to get certain commands sent to it, all using this generic description. Okay, let's go a little bit deeper into the metadata model. We've talked a bit about some of these elements. Let's start to see how they're again associated and some of the other elements within inside the metadata model that they're associated with. So we've talked about a device. It represents a physical device out there in the world as far as EdgeX is concerned and represented by this device object inside of the metadata model. Device profiles represent the class or general characteristics of that particular device. So each device is associated to a device profile. And we also talked about a device service. A device service is representing a physical microservice out there, a physical microservice device service that's in our EdgeX system, and it manages one or more devices. So again, that's our triumvirate that we talked about, these three objects. What else is out there in our metadata system? Importantly, you will see that devices and device services are all considered assets. What is an asset? In our metadata model, this is an interface that defines certain things about the actual operation of these elements. We have something called an admin state and an operating state. An admin state tells us whether or not this particular system, this device or device service, for example, are actually functional and operational. Maybe one of them has gone down. The admin state there would indicate that. Operating state allows us to actually physically lock or unlock that state. In other words, through some sort of human system or maybe management system, we're able to actually lock it down. This is going to be important when, say, maybe the device service is being updated, getting new software, or maybe the device is being replaced with a new device. So there are a couple of admin and operational states out there that any device or device service has that allows us to kind of keep track of its status. And again, some generic characteristics that go with every asset. There's a name, a description, and then this thing called addressable. This is a key component we see throughout EdgeX. What are addressables? Well, addressables are meant to be a very flexible object to help identify the location of something. In our particular case of metadata, that's the location of something like a device or a device service. Now, let me bring up the next slide here. When we talk about an addressable, what we mean by that is an object that represents a way to provide an address for a device or a device service, but that address is by the addressable, maybe a little bit more determined, but it could be something like an HTTP address. So in other words, a URL with a port. It might be an MQTT topic with some sort of maybe cloud address about where that topic is located, or a 0MQ topic. It could be any kind of, let's call it, resource that is addressable as to where these things live somewhere on something like a network or in some space with regard to how we communicate with regard to that device or device service. So an addressable, one might think of simply as something like a URL with a port and a host that offers that particular device service. But think of it a little bit more broadly, because not every part of EdgeX is curtailed to being a REST HTTP endpoint. So addressable is meant to provide a kind of a flexible mechanism for us to address things, be them devices or device services, without having to be always consumed by the thought of it being some sort of HTTP mechanism. Now, addressables are managed by metadata and used by many microservices. Yes, they are in and used by metadata objects, but you'll see them used throughout EdgeX in different areas. Whenever we need to know the address of something, we use an addressable to help identify where that's located, providing some flexibility there as to how we get to that particular service or facility or thing that we need to communicate with. So backing up to my picture again, addressable, as you can see, are associated to an asset. And again, assets could be things like devices or device services as far as EdgeX is concerned in this metadata realm. So if we start to then look beyond the model, and we start to say, well, how does metadata get information about these devices, these device services, profiles, and things like addressables? Well, there's a certain sequence that might happen when things start to come alive inside of EdgeX. In particular, and as a pretty typical case, a device service might be something that starts to come up. In other words, a device service microservice is something that might come up in the EdgeX system. And as it starts up, through its sequence, it will register itself in with metadata and start to provide metadata with an indication of those devices that it's managing. So this sequence diagram helps to carry us through that kind of sequence. As the device service comes up, it registers itself by name. Then it goes out and starts to, that is metadata, gets that information into its database, provides information back to the device service, for example, about what its actual identifier is. Then, as things progress, the device service starts to provide a list of the devices that it's managing and provide an indication back to metadata that, hey, I'm a device service and I not only am up and running, but here are the devices that I'm managing. As it tries to register each of the devices, it may also have to provide information about the profiles that are associated with each of those devices. So that's one way that metadata gets populated. Metadata may also be populated by a process called device provisioning. Not everything comes from a device service. You may, maybe through some sort of system management UI, add a new device into our EdgeX system. When you do that, we talk about a provisioning of a device. And there's a sequence, as you can see here, about how those devices get provisioned. Essentially, again, communicating some of the same information. Here's my profile. Here's all the characteristics and information about my device so that I can get back a new identifier and make sure that that particular device is then associated with a device service out there so that it can start to manage that device. So if you will, gang, there's a set of procedures. There's a sequence of processes that happen with regard to metadata that allow new devices and new device services, along with the device's associated device profile, to be established in metadata so that it now has that knowledge it can share with all sorts of other microservices about what's connected into EdgeX and how you start to communicate with it. There are some additional metadata model objects that I'm just going to briefly discuss here. I'll leave it to you to start to get into some of the details. We have the concept inside of metadata of something called a device report. What's a device report? Well, once a device and a device service and its device profile are established inside of metadata, your system, maybe the device service, for example, wants to suggest to metadata what is going to be collected from that sensor device and in what time frame is that data going to be collected? And what should that data look like? A device report brings together all those, if you will, parameters. It specifies what device is going to be collected, what type of information is going to be collected from that particular device, that is the expected values, and when is that information, that is the scheduled event, is that data going to be collected. So this metadata model suggests information about the collection schedule, if you will, of the device data from devices and sensors. And that's represented in metadata so that the rest of the microservices in EdgeX get an understanding of when, where, and how often, and what should it look like when data starts coming from any type of device or sensor. Now, a couple weeks ago, inside of core data, we also talked about value descriptors. Value descriptors were a object inside of core data. But these value descriptors, as I mentioned then, and now pick up on that conversation, are also used in metadata. First off, what again is a value descriptor? What does that refer to in terms of core data? A value descriptor provides essentially context and unit of measure to a particular reading, the sensor value that's coming up from a device and a device service. Each value descriptor has a unique name, and it describes what a reading from a sensor might look like. For example, it would say, if we're talking about temperatures, here's what a temperature might look like. It has a range between -25 and 125. It's going to be some sort of integer. When you're talking about it, we refer to it under a label of C for Celsius. That kind of information is what a value descriptor does. Now, metadata uses these value descriptors that are stored in core data to help describe the parameters you send for a command. If you want to say, set the cooling point on a thermostat to a device, you need to know, well, what the heck does that mean? When I set a cooling point, what do I use to describe that cooling point? And that's where a value descriptor comes in. If you want to talk about the data being sent by, say, for example, a device, how does the data start to come up from that device after you've issued a command? Again, value descriptors will be used there to say that the device is going to send up to you what its current cooling point is. And again, a value descriptor can help describe that. And when we talk about sensors and devices and the data that they're going to start to collect and send up into core data, value descriptors are used as part of that device report that we just reviewed to help describe what you should expect in the formats and the mins and max of those values that they may be sending. So value descriptors are defined in core data, but used quite often in metadata. And this is what kind of conjoins core data and metadata in terms of describing information flow, both in and out of the devices and device services. Okay, let's get into, with a few minutes that are remaining here, let's get into a little bit of the APIs that you'll find into our metadata system. As we looked at a couple weeks ago with regard to core data, metadata has a collection of what are called controllers that actually manage the creation, the deletion, the updates of things like our device profiles, our device services, and our devices that are out there. Again, the triumphant. But there also are controllers that deal with addressables, deal with schedules, schedule events, device reports, all those things that I just mentioned. Now, let me back up here a second. When we talk about these API sets, we will see, and if you want, you can go out to these particular links for any one of these as an example. Each controller helps to manage that particular type of object inside of metadata. So a device profile controller is going to manage the creation, that is the add, the update, the delete of those particular device profiles. And it also provides all sorts of REST GET requests, so you can query for device profiles by ID, by name, by label, by manufacturer. There are gets galore out there to help query what types of device profiles does metadata know about. In a similar fashion, other controllers help to manage devices. Another controller helps to manage a device service. Each controller helps to manage that particular thing that metadata knows about. Now, there's some rules built into these controllers to help manage the data that's in metadata in the metadata database. For example, there are rules in place in these controllers so that if you try to delete for example, try to delete a device profile or device service that's associated device, it's going to make sure that it stops you and says, well, wait a minute, there's a bit of a problem here. We have an association between a device profile and device that exists. I can't let you delete the device profile until you first delete the device. So if you will, there is some referential checking that goes on in some of these controllers to make sure that the data remains intact. We don't have any kind of orphan information that's in that metadata repository. So lots of controllers out there to, again, provide for a means of creating, updating, removing all of the various different elements, all the model elements inside of our metadata system. This is what is at the core of our APIs. So device, device service, device APIs, addressable APIs, schedule APIs, schedule event APIs, and device report APIs. We also have a set of miscellaneous APIs that are part of metadata. As I mentioned a couple weeks ago with regard to core data, each and every microservice comes with a ping API. This is just a good debugging mechanism. It lets you know whether or not, in this case, metadata is up and running and functioning. And there's also an API out there to actually see what are the value descriptors associated to any one of our devices. As I mentioned, value descriptors help describe for us what type of data the device or device service is sending, as well as how to command a particular device through things like parameter sets. The association is providing a mechanism to know which profiles use which value descriptors, which devices use which value descriptors. This association API will let you query that and determine, is, for example, temperature value descriptor being used by any one of the devices out there. Lastly, gang, there are some important configuration options that you will see in metadata. Each microservice inside of our metadata and or any microservice environment inside of EdgeX comes with an application properties file. You'll see this right in the source code, right at the base of the source code for every one of our microservices today. That information provides a key value pair set to configure how the optionable and or configurable elements of EdgeX work. In metadata, there's just a couple. We have a flag inside of metadata that is called the notification flag. What this particular flag does is allows us to have your metadata system send out an alert or notification anytime a device, that is one of those device objects we talked about in metadata, is either added, updated, or removed. Essentially, this is a nice little example of how the alerts and notification microservice works inside of EdgeX. It's a way for other systems, for either external or internal mechanisms, to receive indication about a new device being connected to EdgeX. So if you would like, and by default it is on, you can configure this notification information about where to send information about those new devices, those updated devices, those removed devices. So take a look at the application properties file inside of the metadata microservice, and you'll see the information about how to configure that notification information to allow metadata to alert others when things have happened to devices. We, of course, also have, because Mongo is used underneath the covers, database configuration. What's the location of Mongo? What's its username and password? These configuration options allow us to change out the database, or again, maybe switch to another Mongo instance if we didn't want them to be conjoined with the core data collection Mongo instance. Then there are some standard configuration options that all microservices inside of EdgeX have. What is the port that metadata runs on? What's the location of the other associated microservices that metadata may need to call? For example, what's the location of the alerts and notification microservice that may need to call on for that notification information? What are the log levels, and what are the reading limits that we're going to allow you to query for? We don't want you to query for everything that's in the database and cause the whole system to crash, so we provide read limit parameters, so you only get back a certain number of devices or device profiles, for example, when you query on that API. Alrighty, gang, that's a quick overview of metadata. Again, at least the first part. Tyler Cox will come in again next week, next Thursday morning, and discuss more about the device profile, how that operates with regard to things like commands and device services. If you will, really starting to discuss branching out from the core services, in this case metadata, into another layer of EdgeX called device services. If you have an idea for other talks, please, please, please let us know. Send me an email, send me a Rocket Chat message, somehow communicate with me and provide suggestions. Metadata will be covered next week. We'll probably look at some of the other services like core, command, as well as some of the export services in coming weeks, but I'm always open to suggestions. So that's kind of our current working list of what the current next tech talks are going to be about, but certainly welcome your input. With that, let's see, what are we doing here? We went a little bit over again today. Sorry about that, gang. I'll stick around here as long as necessary, but we should have a few minutes here to try to open up for questions. Let me see here if I can open up the chat area and see if we have any questions. Don't see any out there right now. And I don't know, Brett, if the lines are unmuted or not, but if you do have a question, gang, about anything you heard about today in metadata, or just with regard to EdgeX in general, happy to try and provide you that information right now. And again, while we're kind of waiting for those typing fingers or questions to kind of roll in, if I can, please let me emphasize a couple of things. If you can, go out, take a look at our MVP for the Barcelona release. We would love to have you provide feedback on that. We would even more love to have you participate and contribute in the development of EdgeX through either the Barcelona release or other elements. So please get in touch with me and we'll provide you kind of a working list of what some of the projects are we have in the forecast for both Barcelona as well as future releases. Also ask you to take a look at the Rocket Chat channel for EdgeX, a great way to post other questions, see what other people are thinking with regard to our community. If you're not familiar with Rocket Chat or how to get and use it, go out to the edgexfoundry.org website, and you will see out there under the developers link a way to get connected to EdgeX Rocket Chat and start to get on those channels to get your questions answered and or see how other people are asking questions and what answers they're receiving. All right, gang, it must be Miller time across the world because I'm not seeing a lot of questions come in yet. Brett, do we have the mics open? Do we want to take open questions or want to?
Yeah, mics aren't open. I mean, anyone's welcome to unmute themselves. If you're having issues unmuting, just throw a message over the chat or email or Rocket. We'll address it somehow, some way.
That's right.
Otherwise, as Jim noted, he's really responsive over Rocket Chat, so definitely leverage that tool. Sign up if you have not already. I'll also note that the developers page also has a link to the various mail lists. And so if there is an area that you are particularly interested, if it's core, if it's security, please do subscribe to their mail lists. That will ensure that you're added to any meeting invites that they assemble as well. So I know that both the security working groups as well as the core are planning meetings next week. And so if you'd like to be on those invites, easiest way to make sure you're on those is just joining the email list.
Thanks, Brett.
Perfect.
Well, looks like I've worn everybody down. I do not see any questions coming in on the Rocket Chat and no sense in prolonging agony and listening to a voice like mine. Next week, you'll get a much better
There we go. I think, go ahead.
This is Winnie from VMware. I have a question. Do you have a page or place where I can find all the REST APIs? And another question, sorry, I have two questions. Another question is that currently, in fact, I tried to set up the microservices and follow your instructions. And but when I try to get the device, use the REST API in your presentation, I can get some, but I cannot find the readings. So I'm wondering, how can I get those readings and with 10 steps?
Yeah, thanks, Winnie, and hello. Good to hear from you again. I know Winnie's with VMware. So great segue to allow me to kind of help you find that, Winnie. So let me.
Thank you.
For everybody involved here, let me kind of point everybody in this direction. And if somebody can confirm that you can actually see the EdgeX wiki site on my display right now, just so I'm not talking in the thin air here.
Confirmed.
Okay, thanks, Brett. So, folks, this is our wiki page here, and you can see lots of categories over here on the left-hand side. For Winnie's purposes and for everybody else's, you will see this link to API reference. You might want to expand that, and what you'll see is each of the layers has an API set, and then inside of any particular layer, for example, when we're talking about metadata, we want to go to the core services layer. let me scrunch that over a little bit. You'll see the various core services there. So you're going to want to take a look if you're interested in knowing more about metadata. Go to the APIs for the metadata service. Now in there, and this is a little bit hidden and it's a bit unfortunate, but we don't have a plugin to readily display the RAML document that gives you a better visual of the API. But you'll see right at the top of each of these API references a RAML link. If you download that RAML document, you can use a RAML to HTML tool. You can look that up on Google, RAML to HTML, and that tool will allow you to convert that RAML document into a nice, easy to read HTML document that you can use to actually go through the API. But if you speak RAML and or you have other tools that can digest that RAML for you, that will actually give you the API winning for any one of our services. And in particular, when you're looking at something like readings, you'll want to take a look at the API for core data. Now, when you say you're not seeing readings, that usually means that there's something wrong at the device service layer. It's not providing or pushing up data into core data. That's why you're getting no readings. There's actually quite a few postings out there on Rocket Chat about that. I know I've seen quite a few people have had some issues there in getting the virtual device service, for example, up and running correctly, and they are not seeing readings. If you take a look at some of the questions out there, that might kind of help you. But if that doesn't, and you're still having issues, feel free to reach out to me either through Rocket Chat or email directly, and we'll help you get up and running. So again, the API reference is where you find all of the APIs for each of the services. And Rocket Chat is usually where you can start to post questions if you're having issues and either understanding or getting something from one of those APIs. So thanks, Winnie. Hopefully that that helps you out. And by the way, gang, just to kind of give you a little bit of a view, if you do use that RAML to HTML tool, you will find that the documentation will come up something like what I'm showing on the screen right now. So kind of a nice, easy way to look at that. You'll even see that there, for each of the APIs, examples in there about the type of data you pass in and what kind of status and response you get back. So some good information in those RAML documents.
Thanks very much. That's very useful. And in fact, as I said, I tried to bring all the microservices, follow your instructions. And in fact, I also used your UI, and which can indicate all the microservices, whether it's working well or not. I do see, in fact, many, at least 30% of the microservices are in not good status. So but from the logs, it seems I checked as your instructions whether those how many services is running. It seems it's fine. So in that case, what should I do to double confirm whether those services, microservices, are not brought up successfully? And should I restart separately those microservices?
Yeah, Winnie, lots of possibilities there that could be issues or concerns there. What I always tell people too is kind of look at EdgeX. Yep, it is a collection of microservices. It is a bit of a complex beast with all those pieces. So maybe what you want to start to do is kind of bring up things one at a time. And start to work through the issues one at a time. That's also why, if you take a look at the documentation out there, we also provided this page called the demonstration API walkthrough. It tells you about how to bring things up, and it sounds like you've already done that. It also takes you through a collection of API calls, seeing each of the API calls go through, making sure that you get back a appropriate response from each of those early API calls, gives you a pretty good indication about what's working and where maybe something is starting to fall down and not work appropriately. So I'm going to point you to that link as well. If you kind of work your way through, and I know it's a long document, but it also helps describe exactly what's going on in each of the microservices, that might help you start to diagnose where some of the issues are, as it kind of takes you through piece by piece, all the way through the various services, all the way up through to the export side on the northbound side, and helps you diagnose things.
Okay, I got it. Thank you very much.
You're welcome. Thank you.
One more question. Sorry, I have too many
Sure.
questions. Yeah. So must I bring up all the microservices to get to successfully get readings?
No. In fact, again, this demonstration will talk a bit about that. But as a minimum, if you want to get readings, if you want to get readings that you manually push through, really all you need is core data, the database, and metadata. Believe it or not, that's minimally all you need. If you want to actually have, for example, a device service actually start to push data in, let's say, for example, the virtual device service, then you would need that service as well.
Yeah.
Yep. Yeah, so really, you can start development minimally with a very few set of services to at least start to get the data flow operational. When you want to start to do some more complex things, if you want to actually collect all the logs together into one log file, which is what the log service do, then you might want to add some of those other device services. But you can slowly add services and piece things together as you start to become more familiar with just the basics.
Do you have minimum requirements for your memory and the processors?
Yeah, great question, Winnie. And the answer is there are some guidelines out there where we're telling people you probably want to have, you minimally have to have at least 2 gig of RAM. In terms of processors, things like our gateway only have a couple of processors, so we're not saying you have to have a lot. But I always tell people, at least right now, if you can operate with at least 4 gig of RAM and a couple of processors, that's what I would recommend minimally, at least to get started. As you start to add in more services, in particular when you go to things like rules engine and lots of devices, you may need more. Obviously, we're working on reducing that, and things like our Go services are going to help greatly with that. But today, those kind of minimum standards are what we are suggesting. And I know it's in our wiki page someplace. I forget exactly where. I think it's in our get it started guide someplace about some of those minimum standards. But recommend, I would say, 4 gig memory and at least 2 processors if you're a developer getting started today.
Okay, got it. Thank you.
You're welcome, Winnie. Michael, you have a question out there. Michael Hathaway, I think I see a hand raised. And you have to unmute yourself there, Michael.
Okay, I'm here. I couldn't unmute myself. Hey, so this was very helpful. Very interested in the device registration process with regards to metadata. So 2 questions. One, discovery. You have a device that has an IP address that EdgeX isn't aware of, and 2, it may have some security like an API key. And have you thought through, or are there provisions for registering a device with the system, providing its IP address and a key for access security?
Yeah, great questions, Michael. Let me address that on several different levels. So when you talk about what we call provisioning, essentially associating a new device into EdgeX and more precisely into metadata. So there are a couple different ways that you can get a new device associated to EdgeX, as I kind of alluded to in my talk here. There is what we call the bottom-up approach. That means a device service somehow discovers a new device or knows about a new device and pushes that information up into metadata to let EdgeX know about it. A top-down approach may be that some application, maybe it's some sort of system management system, or maybe it's a man on some sort of user interface at the application layer that does it, but somehow something above EdgeX knows that there's a new device and then makes API calls into metadata, and that pushes or provisions a new device. When you do so, you also have to provide more details about, for example, well, where is that device located and how do I communicate with it? So those are kind of the 2 scenarios. Now,
okay,
based on what you're talking
about. So we could push down an IP address and say an API key from a higher level service to basically register a device and let EdgeX know, here's this device, it's using this protocol, here's its IP address, and you need an access key.
Exactly.
So we can do that from a higher level. Okay, cool.
Yeah. Now I have to caveat that a little bit in that as we built EdgeX initially, for those who are not yet aware, there aren't a lot of security features built into EdgeX today. That was done on purpose. We knew that the community had to be on board and had to be providing us guidance on how and what types of security mechanisms are we going to use to guide lots of parts of the EdgeX system. So when you start talking about security keys and tokens, you may be left a little bit wanting. In fact, I am pretty much sure you're going to be left wanting today with how to provide that information into a lot of parts of EdgeX. It's coming. The security working group is working hard to help us define that. So you've got the general principles, right? That you could, for example, have some sort of application push that information down. Today, it probably would not be inclusive of some of that token information that you talked about, the security authentication information you talked about. It would just be, hey, here's where this device lives, here's the IP address. Tomorrow, that will also be inclusive of some of that security paraphernalia. Does that make sense?
Well, we'd be interested. Yeah, we'd be interested in working with the security folks. We've been connecting legacy devices to IP for quite a while, and a lot of legacy systems just have no internet security at all. So we've had to deal with this problem for quite a while. Thrilled to be working with you guys, but we've got a mechanism that it sounds like what you talked about would work, where a device can register remotely. We can get its IP address, assign it a key, and then push it down to EdgeX. Or if EdgeX takes over security and assigns the key, being able to push that down to the device API. We're not married to either one. We do it the former way right now, but would welcome working with you on either mechanism.
Absolutely, yeah. We feel going forward we're going to have to provide both, right? Sometimes things come from the top down, and sometimes they come from the bottom up. And on that end too, the device service, the way we've built the device service, which per our diagram here, really that's this collection of services down here at the bottom that communicate with the sensors directly. Inside of the device service is a mechanism already to scan, if you will, discover new devices that may, as part of that process, may in the future also include information about, okay, well, I've discovered this new device at this IP address, but what credentials do I need to know, and how do I provision those and get those pushed up into metadata as well? So,
and not all those protocols are discoverable. So.
Exactly right, yeah. Well, that's why we've left, exactly right. That's why we've left the discovery part of every device service to be both optional and implementation specific, because we know each of those processes are either going to be different or maybe non-existent, depending on the type of system you're talking about. So hopefully we've started to provide for some of that, but we would absolutely welcome you, Michael, in the security working group. Communicate with Brett. He can get you set up for those meetings.
We will.
I know they are, they're having a big meeting, a face-to-face meeting coming up sometime in August, where I think a lot of the stuff's going to be laid out.
So does the top-down mechanism into the metadata service, is that functioning today, or is that something we kind of need to wait for? Because we're ready to start playing with this a bit. So. Yeah,
no, absolutely. Those APIs are already there. I would encourage you maybe to tune into the talk next week, because Tyler's going to talk.
I'll be there for sure.
Yeah, and he'll talk profiles. He'll talk about how device services and metadata communicate, and what happens when you call it from the top down or the bottom up. So those are there.
A quick question there. I'm assuming, since it's Mongo and it's document based, if we needed to insert data into that metadata that's required for applications to talk to a device, we could do that.
You certainly could.
A fixed schema?
Yeah, we have a fixed set of collections that are out there that are initialized when EdgeX is first deployed. Now, having said that, and we're not going to prevent it ever, but I would discourage people going directly to the database, right? As soon as you do that, you bypass lots of features and you can muck stuff up. But the idea is the metadata service around that database is what helps protect it. But we absolutely want to provide that capability, especially, if there was some massive batch deployment or something, we could see where maybe from an expedient standpoint, you just want to pour that information right in.
Does the API to establish a device top down into metadata, does that allow you to add some key value pairs that are going to be required for an application, or is it kind of a fixed schema right now?
And nope, there are some flexible elements to it. I'll let kind of Tyler talk a little bit about that. There's flexible elements in and around things like the profile and how you issue commands. He'll talk about attributes and resources next week. There are also some flexibility going back to the value descriptor. You know, that's really a key value pair that associates, you know, what kind of information you may be sending, and that's a bit of a flexible element too. That association of the value descriptor through key value pairs allows you to kind of change things out pretty dynamically as well. So I don't want to say everything is extremely flexible. There are some places where we have to draw some lines, but we've tried to make it flexible to allow for all sorts of inputs going forward.
Well, that was very helpful. Thank you.
You're welcome. Any other questions? And by my watch, we've reached the top of the hour. So we've consumed your hour. You can at least report to your boss that you spend it listening to some babbling guy about EdgeX, and hopefully you still get paid for that. Any other questions, comments, concerns? Alrighty, gang, it's been my pleasure to be with you here again this week. Look for Tyler's talk again next Thursday morning, and I'll be back with you in a couple of weeks. We'll probably be talking about either core data or, core command, or maybe the export services, but we'll continue on these talks to help bring you up to speed. And please, please, please look to participate in EdgeX, and not just learn about it, but jump in there and help us build this thing. Talk to you all in a few weeks.